attention. So, good afternoon, everyone. Good afternoon. Before we start going over the bell word, which Justin did get all 4 marks, very good. Just a couple of things. First off, remember this unit, because I'm keeping it a little bit light, it's only going to be the 5 lessons, a review day, and a test. You'll have a test, your Unit 4 exam, before winter break. It's going to be the Wednesday before winter break. I am begging you to memorize your prefixes, your functional groups. Those are like things you've got to know. Because for the rest of organic chemistry, if you don't know your functional group, or you don't know like the name, you're going to be in trouble. And I don't want anybody in trouble, so that's why we're going to do like checkpoint before winter break. That also gives you the opportunity to take a little bit of a mental break over winter break, which will be well deserved. And then when we come back, we'll continue. But you will have your Unit 4 exam on the Wednesday before winter break. We've got lessons all the way through next Thursday. Then we'll have a review day on Monday, and then we'll have the test on Wednesday. Okay? Got it? Yes? All right. So, yes, Hakeem.
The test will include only Unit 4, right?
Only organic, up through what we do next Thursday. So, everything we do this week, everything we do, it's only like 2 weeks of material. But it's a lot of the stuff from what you're supposed to know from pre-H. So, next thing. I don't know if I had went over with my previous classes last year. I can't remember or not. There's a way you can memorize your meth-eth-prop-bute. Meth-eth-prop-bute. There's a little acronym you could use to help you with it. It's called monkeys eat peeled bananas. So this is a mnemonic device you could use. And it gives you the order. Meth, eth, prop, bute. Monkeys eat peeled bananas. That gives you meth, eth, prop, and bute. So if you're struggling with the order, monkeys eat peeled bananas. That can help you out with that. Yes, propyl. So you may want to write this down if you are having a hard time with memorizing that. Remember, from pent on to dec, technically those are the geometric prefixes, pent, hex, hept, octagon, dec. Those are ones you should already have. But if you have to go back and memorize those as well. So today we're going to learn about isomers. It is a big topic. It is new for everyone. Unless, Janie, you learned it in virtual schools? No? This should be new for everyone. Everything up until this point we technically had went over. If you had me for previous, everything up until this point we had already went over. So this is the first new lesson. And so before we get started, let's go ahead and go over the bell work. Give the name of CH3C3CCHO. Notice how they did it, the sneaky. They had the 3 carbons. You have to understand that this is the central carbon right there, right? So it would have been C. And oftentimes it helps if you just expand around a carbon, and then you see CHO. And you've got to interpret CHO as an aldehyde, not an alcohol. They were a little bit kind in that they literally drew it in the next question. Like the same thing that it's right there. Like it's right here. And they drew it in the same manner I just did. This is kind of like a mix of displayed and structural. It is really structural. This is method 1 of structural, where you don't collapse everything around it. You just expand your methyl groups to show what's going on. But this is like a weird version of structural. What's going on? Because you're showing the functional group as well, what you actually see. So what's the name of this? It's an aldehyde, so the ending has to be AL. So they need you to be clear with your A's versus your O's. That's why I chose this as a bell word. And so we know the ending of this is going to be 3 carbons in a row. It's propan, al, right? Then on carbon 2, you've got a methyl group at the top, and you've got a methyl group at the bottom. So you were supposed to put 2, 2, dimethyl propanal, and then like I'll smush it into one word, right? That was the first mark. Yes. You can get, there's like a lot of them. You just have to, Merry Christmas. figure out how to connect it in. Hybridization, this is old school. The idea is you count the groups around the carbon in question. If there's two groups of electrons, like two atoms coming out, then it's sp. If there's three groups, it's sp2. And if there's four groups, that means like four atoms coming out of the carbon, then it's sp3. So this is sp2. So far, so good? So can I test hybridization in this exam coming up? Anything that's related gets smushed in. So you're given organic molecules, you may be asked for hybridization. Just bringing it up. You could be asked to count the amount of sigma bonds and pi bonds. I believe I bring that up in today's lesson. All right, next thing, number 2. This is actually a question I didn't pull from AS. I pulled it from a previous exam, which you never have to take a previous exam at the end of the year. But this is what a question might look like. So it says product structure of the molecule of vitamin A is shown. So it's an incomplete structure. And they ask you some statements. So it's actually very similar to the structure of what a paper 1 would be. But the question is like a lower level, paper 1. Which statements about this part of the structure are correct? What is saturation? I know we went fast over it. Go ahead.
If there's like all the bonds, like there's no double bonds.
No double or triple bonds. Single bonds only. That's correct. Meaning that what you have is saturated with hydrogens. It has the most hydrogens it could have. Saturated means filled. Just like if we have, a paper towel and you saturate it with water, what that means is that you filled it with water. Saturation just means filled. So saturation of an organic molecule means filled with hydrogen. And so it's only alkanes. Well, is that true? Is this saturated?
No.
Definitely not. Statement 1 is out. So A and B are out. The next one. Are there 2 alkene groups? That's an alkene, right? And that's an alkene, just to point them out. Those are alkene groups, so that's a true statement. And the last one asks, is this a carboxylic acid? And that is not a carboxylic acid. This is actually a alcohol of primary nature. But it's an alcohol. And so the answer here would be just statement 2. Yes? Next one. This is, and I believe this is an AS question, but I don't know if I pulled this from a previous or an AS exam. I guess it could be from either. But this could be an AS level question because I've seen many AS level questions where naming esters, like just straight up name this ester, is a question. So there was a little bit of a source of confusion here. How do you know from the structural format of an ester if your ill group is on the left side or if your ill group is on the right side? And so what I usually tell students to do is expand the functional group, meaning just around the carbon that matters. Expand it to display. What would it look like displayed? And so I rewrite this out, CH3, CH2, CH2, and then you've got this carbon has to have 2 oxygens on it. The way that it's written, they're written in this direction, so you put the 1 oxygen up and the 1 oxygen to the right, like that. And then you keep writing CH2, CH2, CH3. This makes it a little bit clearer that your cut has to happen right there. This is the single bond, the ill side. This is the 8 side, O8 side. And so then you just count your carbons. 1, 2, 3. That is the prefix for propyl. So this is propyl. And 1, 2, 3, 4. That's butanoate. And you can see how incredibly important the meth S propute is, right? Those are used all the time. So monkeys eat peeled bananas. That's a way to go about it. Propyl butanoate. The answer here is C. All right, how are we feeling so far? Good about it? Don't forget the functional groups assignment. I believe I had made that due on Sunday. Am I right? Anybody who checked? I put that due on Sunday. I think I told you all the reason why is because many students were actually either participating in induction last night or were part of like people who were involved in induction. And so I didn't want to make work due the midnight of a day where you had induction. I do want to tell you though, I posted messages to some of you because I will be grading these assignments on Sunday. We got to stay on top of these assignments because your test is coming quick. So I will be grading your assignments on Sunday. So if you haven't turned in the one on naming and drawing alkanes, make sure you get it done as well this weekend. I sent a message to everyone just to remind you, hey, if you didn't do it, make sure you do it before I throw the 0 in the Facebook. Not a fan of giving. I need to send reminders that this has to get done. All right, so bonding and organic molecules. We're gonna go ahead and first go over, I think we have to go over the objectives. Here's what's new. We are ready to begin. What's new? Describe structural isomerism. So the title of today's lesson is Isomers. Have we heard of something with an iso before in this class? Isotopes. Okay, let's connect. Isopropyl's a thing, yeah. Isopropyl alcohol. That's a thing. That means that's an isomer of another type of alcohol. Isotope. What was that? Isotope.
Like different types of.
So we had the same element, but it had different amount of
Neutrons.
of neutrons. And so this meant that the mass change, one version could be radioactive where the other one isn't, but the actual chemical reactivity was largely the same, or completely the same. And so the word iso in the front means something's going to be the same and something's going to be different. That's just to give an idea of where we're going. I haven't yet defined what an isomer is. I'm just saying this prefix we have seen before. We're going to apply this now into something different in organic chemistry. When we begin, you have a little bag in front of you, or everybody should have a little bag in front of you, and I'll be explaining a little activity you're going to do as we start to work on isomers. It's the little models, the little molecular models. You're going to be doing something with those, or a couple things with them, because it'll help to understand what's going on a little bit better. All right, so let's go to the objectives. First objective, describe structural isomerism. Structural isomerism. And its division into chain, positional, and functional group isomerism. This is number one objective. If you have no clue what that is, that's okay. We're just going through the objectives. Remember, you should, as we go through each objective, see if you know what it is already by putting a check mark or an X. Remember I told you that at the beginning of the year? You should do that. If it's an X, it's okay. It just means you don't know it. We're going to go over it. If everything's X, it means you've got to learn everything from scratch. But actually, the last two lessons, some of it should have been check marks if you had taken pre-ACE last year and you kind of remembered. 13.4.2. Stereoisomerism. Sounds like a music, right? When I hear stereo, I think music. It means something different. But and its division into geometrical. I know the word geometry strikes fear into the hearts of many. It's geometrical and, have you ever heard the word optical before? So these words are interesting. What are all these words going on? This is sounds like sound, this sounds like eye. What's happening? We'll find out. Describe geometrical isomerism in alkenes. So you want to point out geometrical of the variety cis-trans are in alkenes, and explain its origin in terms of restricted rotation due to the presence of pi bonds. Well, that sounded like a lot of words. We'll get to that. Remember, if you don't have any idea what this is, put an X. It's okay if everything's an X today. It's all new. Explain what is meant by a chiral center, and that such a center gives rise to two optical isomers. Identify chiral centers and geometrical isomers in a molecule of structural formula, including cyclic compounds, meaning like cycloalkanes, the stuff that we've already learned how to name. Deduce the possible isomers for an organic molecule of known molecular formula. So it looks pretty hefty. Sounds like a lot of weird words we've never heard before. I have, if you haven't possibly heard these words before. So we are going to pretty much start from scratch with what is an isomer and go from there. So before that, let's break it down a little bit into something we've already learned. Talking about bonding in organic molecules. Remember the carbon makes 4 bonds? Remember, I'm gonna leave this up here. You can even have that for the test. I'll give you that for the test. You're welcome. Carbon makes 4 bonds. Remember that it could either make single bonds, actually. It can make double bonds, carbon. It can make even triple bonds, right? So these 4 connections around carbon, they can be organized in different ways. You could have a carbon that has 4 single bonds. You could have a carbon that has a double bond with 2 single bonds. You could have a carbon that has a triple bond and a single bond. And we had to be able to figure out if these bonds were sigma bonds or if they were pi bonds. You remember that? Single bonds are sigma bonds, and double bonds and triple bonds are pi bonds. So in the first version of carbon I've written, where it's got 4 single lines coming out, how many sigma bonds do you have? 4 sigma and 0 pi, right? The second example was that
3 sigma.
3 sigma, 1 pi. And here,
2 sigma. 2 pi.
sigma. The reason why we're bringing this up is because remember when we read through the objectives of like weird words, the pi bond word was there. So you've got to remember what that is. Yes. There's somebody else who asked? Yes, you went. So yes, you went. All right, this is something that we remember, kind of, sort of. Single bonds, sigma bonds, pi bonds are for your second and third bonds, if they exist. All right, so can you solve this? And yes, this can show up on your next Unit 4 exam because we're back here again. Unit 4, we can ask sigma pi bonds. I think your sigma bonds are too small. Remember, you have to look at it in display format. So you may want to consider expanding out all of your hydrogen. So like here, you should understand this is this, and this, right? H2 here would be 2 hydrogens. Here would be 2 hydrogens. Here would be 2 hydrogens, and here would be 3. What do we got?
22, 25.
The pi bonds, are those easy to pick out?
Yeah.
Yeah.
Those are the second bond of the double bond, right? So we know that we can take out 6. That gives us 1 that we could take out. So now let's count the rest. This is why I said you may want to use colors or highlighter or something. I'm going to use a different color pen. I'm going to write a line through each of my sigma bonds. So 1, 2, 3, 4, 5, 6, 7, right? Because the first bond of a double bond is a sigma bond. So I'm up to 7. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Answer is? Are we okay with that? You'll notice a lot of times in this class, when I'm teaching a new topic, I'll go back to old topics because at the end of the year, you have to know everything.
Oh wait. 2 like CH is connecting to C. Do those also come from?
So if it says CH2, that
H2
means
connecting to C with double.
this has 3 sigmas and 1 pi. Like this exact connection, that's what I was saying here. This is 3 sigma and 1 pi.
Oh, okay.
3 sigma and 1
That's
pi.
why
You're probably missing 3, right? For the first bond of the double bond.
Yeah, I was.
All right, so here we are. Before we continue, I have a little activity for you. So you've got a little bag. I saw some faces look happy, some faces look not so happy. Okay, it's meant to not be so bad. You've got a Ziploc bag in front of you. In your Ziploc bag, there should be 6 black spheres. Those 6 black spheres represent 6 carbon atoms. You should have 14 white spheres or semi-spheres with 1 opening. Those are hydrogen atoms. And you should have 19 single bond connectors. Those are the short little white connectors. Build a molecule. That satisfies the octet rule. I'm going to give you about 3 minutes. Build a molecule. You already did it. I'll give you some time here. Build a molecule with your 6 carbons, your hydrogen. Just build a molecule. This is to teach structural isomers. This has a purpose. You can't fail, you said?
I can't fail. You can't fail. Through association.
Just build a molecule. You got to build a full molecule using all those atoms. Got to connect it all together. Connect them all. Connect them all. You got to connect them all. Do you need more time? To build all those connections? All right, I'll give you a couple more minutes. You've
I
got
see
4.
one. Just give me some last one.
Yes. Build a full molecule. You have to use every connection. So there's no spots left.
Yes.
All your carbons must have a connection. You're not supposed to make a ring.
What?
It's not going to work. You have to build a molecule that has 6 carbon atoms, 14 hydrogen atoms, and 19 single bonds. Yes. Take pictures.
5.
3 minutes. Build a molecule. It has to be an alkene, right? C6H14, not a ring on this one. It has to be one molecule, so you're not done. That looks like Fido. Well, we did that.
How do we connect this?
6 carbon atoms, 14 hydrogen atoms, 19 single bonds.
Rebuttal. I feel like we're missing something.
Wait, what?
Yeah, we are.
Ah, here it is. Here it is.
Where is it?
Yes, 6 carbons, 14 hydrogen,
There you go.
19 connections. What have you made? What have you made?
Let me see it. Let me see it. Let me connect this.
You got 2 minutes. Make your molecule.
I already have it.
You're not complete. You're not complete. Complete your molecule.
No.
Yes.
It's just hexane. Right?
Not necessarily.
Hexane.
You have to make hexane.
Oh, there's
Or
definitely
do
something else.
something else. I know why everybody's making hexane.
I want to do something else.
You want to do something else? You've got 1.5 minutes. Make something that has C6H14.
Now, hear me
You don't
out.
have to take it fully apart. No, I'm not hearing you out. Just take away the seeds. Okay, so we'll do it. Bam.
1 minute. 1 minute till we continue. Hakeem, I'm gonna use yours as an example. Okay.
So it's similar.
In 1 minute.
Oh.
So you made a thing. Is it alright? There's one right thing that can be used. You made a thing. It's not nothing, you made a thing. What is the thing you made?
Wait, let's go first or those?
Ah, look at this group here. We have one group that has made something different. Keep that. Don't take it apart. I want to talk about it. I want to talk about it. So, good job.
What they do? How'd they do it?
A long way. We already finished. I just want to redo it because you made hexane, right?
Y'all
You're
made
not
a
special.
mistake. Everyone
Everyone
made
made
a
hexane.
mistake.
I want to be special.
They're already special over here. All right, time's up. So let me get your attention again. I gave you some time. At this point, I need everybody to quiet down again.
No.
I want to talk about something here. We're going to go into isomers. With C6H14, many, if not most of you, made hexane, right? Which is an alkane. But is that the only combination of C6H14 that exists? Could you have not arranged it another way? 6 carbons and 14 hydrogens. So this group right here actually already did that. They came up with, this is 4 carbons in a row, and they did 2,2-dimethyl butane. The same atoms arranged in a different manner. Look at the structure. One's a straight line and the other one is more compact. This actually, even though these molecules have the same molecular formula of C6H14, they're different. They react differently. They have different physical properties in terms of their melting point and boiling point. We call these isomers. And so what is an isomer? A structural isomer. Compounds that have the same molecular formula, but different connections, different molecular structures. We call these structural isomers. Hold on to these. Don't do anything else with them for now, but we will be going back to the kits in a little bit. So, same molecular formula. Remember I told you iso meant something is the same and something is different. So if I have the same amount of carbons and hydrogens, but I can arrange it in a different manner, this is called a structural isomer. Now, what do I mean by arrange it in a different manner? Literally, let me use Hakeem, like I said as an example. I could break off the end of this. And instead of having hexane, having 6 carbons in a row, I have 5 carbons in a row. And I could move this last carbon to the second carbon, and instead of having hexane, what do I have now? This still is C6H14, but it is now pentane, and I've got a methyl on carbon too. I've got 2 methyl pentane. I literally rearranged the atoms and got a different structure with a different name. So the way you're going to figure this out is if it has a different name, then it is a different molecule. That's how you're going to figure it out. So given the information I have now given you, what if you were given C5H12? Look at the top now of the slide. How many different ways could you rearrange 5 carbons and 12 hydrogens? I'll let you think about it. Yes. You could probably come up with one, but it is complicated when you have alkenes. We'll see that in a little bit. How many? You may be asked to draw them. You will be asked to draw them. How many different ways could you write C5H12? Now that I've shown you with C6H14 that there are multiple different ways that you could arrange the carbons and hydrogens. Think about it. We're going to go over it together in a little bit.
Yes.
No, definitely not the entire formula. More than 248 or number 1.
version of C5H12 where I have 5 carbons in a row?
Yes.
It's an alkane, so this would be 1, right? Do I really have to write all the hydrogens if I'm just being asked for an amount and I already know this is an alkane?
No.
You could literally just use the carbon backbone to figure it out, right? So this is one option. This is named what? Pentane. Now what can I do? No, if I do a double bond, I change the amount of hydrogen. It'll become C5H10. What could I do? 4 in a row. And instead of having the carbon on the end, you basically just split it off. You break the bond and you move the carbon somewhere else that's not on the end. So it has to move to one of the central carbons. Yes.
I'm not sure if I did it correctly, but at the very least, 4.13 elevated to the 21st possibilities.
I think
I say 4. 3 possibilities.
This is the second option. How do we know that this is a different arrangement? It will have a different name. Different arrangements, different isomers have different names. So it may greatly benefit you to write the name after writing your possibility because you may accidentally write the same thing twice otherwise. So what is this?
2-methyl.
2-methyl, and this is the carbon skeleton. So I'm just not showing all my hydrogens. Oh, I mean, if you want me to, I can. 2-methyl butane. That's number 2. Is there anything else I could do?
Yes.
If I move this carbon, pay attention real quick first though. If I move this carbon here, would that be an isomer? Like if I did this, is this a new isomer? No, you actually just took this and just moved it around because remember molecules are 3D, which is why you have the little pips there. Because you could just switch it around, it's the same thing. Which is why you said count left to right or right to left, whatever gives you the lowest number. So this is not a new isomer. Yes? Because this is also 2-methyl butane. Okay, so somebody suggested instead of having 4 carbons in a row, putting 3 carbons in a row.
Oh, you can't do that. That makes a lot more sense.
So I can address what you said, but the right way to do is 1 up and 1 down, right? And this would be 2,2 dimethyl propane. It has a different name, but it has the same amount of carbons and the same amount of hydrogens, so it is defined as a structural isomer. If you had brought up, it's a good thing to bring up what you said.
Yeah.
What if you did 3 carbons in a row and then you stacked the 2 carbons on top of each other? What would this be? No, not double bond. Double bond changes the amount of hydrogen. What would the name of this be?
It'd be
What's the name of this?
2-ethyl.
Well, let's try it again. I'm going to make it a little bit clearer if I can. What's the name of this?
2-ethyl. 2, 3.
How many carbons in a row are there here?
3.
No. 4. 4.
4. Oh, you're correct.
Oh, right. This is 2-methyl butane. Again. We already did that. That's right there, right? Which is why I said write the name if you're, it helps to write the name. So how many do we have? 1, 2, 3. The answer is, there are 3 variants. If you have another one, show it to me. See if you have another option. You have to prove it to me
But you
though.
could have it in 1, 2, 1, 1, 1, 3.
Can you have a methyl on carbon 1?
Oh,
Can you have a methyl on carbon 1?
Okay, that would be just pentane.
Right, it goes back to the same thing.
That
It
makes
cannot be an isomer if it's the same name. It means they're connected the same way. If it has the same name, it's the same thing. So far, so
They
good?
have to stick out from the same, like it would have to be.
They have to be on a
open
different,
all
like you
one
literally
and-
have to go like this and move it
So
somewhere
it's
else.
just pentane, 2, 2, 1, 1, 1.
Yes.
No problem.
All right, so now can try another one. This question asks you, so this is an exploration question, to draw all isomers of C4H8. Would it be helpful to know before you start drawing what type of molecule this is? Meaning, is this an alkane?
Yes.
Is it?
No.
C4H8. If you were to draw C4 and make
you
it
need two.
all the hydrogens, you would need how many? You would need 10, right? This C4H8 is missing how many hydrogens? 2 are gone, right?
So what do you have to do?
So what is it?
Is it a cycle? Is it a cycle?
It's either an alkene, and somebody else mentioned, David, there's another way to remove 2 hydrogens. That's not an alkene. You could put it in a ring.
Oh, or you could do double.
So it's an alkene or it's a
Oh,
ring, a cyclic structure. So now that I have given you that information, see if you can draw all the isomers of C4H8.
one cycle.
How many do you have? Draw them all. Any format you want. Draw them all. And let me know how many you get. Get back at 4. See if you can put it So how many ways can I arrange 4 carbons and 8 hydrogens? Let me know if you think you got them all.
You can't go lower than propane. You have 2.
There's more. There's more. More than 4? Yes, there's more than 4.
Right. I do that.
Yes.
Double one to a different.
That would be an
Change the
isomer,
name, right?
yeah. Because that means you're moving the hydrogen to a different. Like anytime you break a bond and you move an atom from one carbon to another,
I know this.
Like with 30.
have a ring. This is one of them. So you've got 1, 2, 3 so far. There's more.
3.
You've got
Oh, wait.
Double bond? No. You didn't even have H's. No. Oh.
any format you like.
8.
Some people may prefer to write displayed to show everything. Some people may prefer skeletal. As long as you know it's alkenes and rings, it works out.
Are you ready?
Yes. To check? What do we got? All right. 1, 2. This is the thing with that. One is skeletal, one is displayed.
1, 2, 3, 4, 5, 6, 7, 8. Oh, it's right. 3, 4, 5, 6, 7, 8, 9. I was wrong. I can't count.
You had 2, I have 4.
All right, 1 more minute to think about it yourself till I go over the answer.
I'm double bond. Oh no. Is that right? That's right. I'm smart. Back.
Removing 2 hydrogens makes 1 double bond or closes 1 ring.
I've done a total What?
All right, I'm gonna go ahead and reveal the answer in 15 seconds. Wait, there's a triple bond there. Why? Could be double bond. But how do you have two double bonds? The hydrogens don't work out to be correct. That would be C4H6. Like, that doesn't work. This has one hydrogen on this carbon, no hydrogen on this carbon, two hydrogens on this carbon, and three on this one. 3 plus 2 plus 1 is 6. That's not C4H8. There cannot be an alkene. I mean, an alkyne. There cannot be an alkyne.
How many are there? There's more than 4 though.
1, 2, 3, 4.
Oh my
1, 2,
goodness.
3, 4, 5, 6, 7, 8.
I don't know what
Yeah,
you
it's like
said.
3 to 1.
Oh, this one doesn't get any. You count them, they won't be right. All right, let's go to the answers. So, first one, did you get that there were 4 carbons in a row? 1 alkene on the first carbon. This would be, I'm just gonna write displayed so that it proves the amount of hydrogen. But if you had written it like this is the same thing, right? This is but-20.
Oh my god. This is what we were missing.
Then this is the first one. The second one, if I take the double bond and instead of putting it on the end carbon, I put it on the middle carbon, this moves the hydrogen atom. If the atom moves, we have a different isomer. So the next one is 4 carbons in a row, but the double bond is now on the second carbon. Now you have CH3, CH, CH, and CH3. The amount of hydrogens worked out. If you had chosen to do skeletal instead, this is it. Right? This is the second one. The name of this is but-2-ene. Different name indicates you have an isomer. Same name means same molecule. So always check with the name to see if it's right or not. All right, so I'm up to 2. What else is there? There's another one with an alkene though. You could do 1, 2, 3 with a double bond, and then a methyl sticking out, because that doesn't break the octet rule, right? And this would be 2 hydrogens, 3 hydrogens, just to show display. 3 hydrogens, and what's the name of this? 2 methyl propene. Yes, different name. That's number 3. Check to see if you get each of them. And this would have looked like this, something like that in skeletal. That's the option in skeletal. As somebody mentioned cycle. So we've done the alkenes, we've exhausted the alkenes, but now we have the rings. So we could do 4 carbons in a ring. Each of these carbons would have how many hydrogens? 2. And so this is also C4H8, but connected in a different way. What's the name of this one? Or just a box if you went that way. Cyclobutane. So now whenever you see a square, that's not a square. That's cyclobutane for organic chemistry. So just FYI. And there's actually one more. Did anybody get that?
Let me see.
The last one would be cyclopropane with a methyl sticking out.
Oh, this one.
Yes, that would be this. Cyclopropane with a methyl sticking out. Right? So then, if you check your hydrogens, it works out. They are going to be 8. And this is 1, 2, 3. It also looks like this. And this is methyl cyclopropane. So, can and will you be asked to draw all the isomers on your test for a specific molecular formula? They can and they will. So this exercise is an important one to follow along with. We're going to do it again though. So there's another one. Next one is a paper one question. However, for this one, read it carefully. It says, how many isomers with the formula C5H10 have structures that involve pi bonding? What does that mean?
Double bond.
Alkenes. It's C5H10, so do you have alkynes?
No.
No. This is the formula for an alkene. So find all the alkenes, and would we include cyclic structures here?
No.
No, because those are single bonds. So only find all the alkenes that have the formula C5H10. I've now walked you through this once. Try it again. C5H10. See if you can come up with the amount. You can do skeletal or carbon backbone. It doesn't matter. It's only choice.
It can't be cyclic.
It can't be cyclic because it has to have pi bonds, which means double bonds. So that's where the two hydrogens are missing. So see if you can find it out.
Yeah, go draw it.
You have to draw it, yes. So if we did C5H10 cycles, just to prove, why? And we did this. And we did this. Right? This is it. Cyclopentane. Does this structure that is C5H10 have pi bonding? Pi bond means double or triple bonds, right? So no cycloalkanes have double or triple bonds with the formula C5H10. Right, because the way to take away the two hydrogens was to close the ring, not to create the double bond. So here, this would not be a variant. And neither would any other ring for that reason. So it has to be alkenes only. So see if you can work through the process. What can you do? It helps to draw them and name them.
4, 5, 6, 7, 8, 9, 10.
You can only use one double bond. Every double bond takes away two hydrogens. Right? Oh. If it fumes at the top, extra thinking.
Well, I thought it continue wrong. It just means they have not been structured.
All right, I'm giving you until 1:30. Let me know if you come up with an answer. Does this hurt your brain, by the way?
This one is fine.
Like the rearranging the molecules? Oh, that's what chemistry. It's more math oriented.
I'm struggling to get 3, so.
There's more than 3.
So.
So just FYI.
I'm gonna fail this unit.
No, you're not. This is the learning part.
It is.
So what can you do? You have to rearrange the atoms in a different way. They have to have the same amount of carbons and hydrogens, but you have to rearrange them in a different way, which means break stuff apart and move it other places, right? So that's to result in a different name. I'll reveal the answer and the isomers at 1:30. I'm giving you some time to think through it. You gotta struggle to grow. You gotta try it yourself. To grow, you have to struggle. Not everything comes easy right away.
You found 4 already?
So this is kind of like a puzzle, right? Chemistry puzzle. Chemistry puzzle
1,
size.
2, 3.
Oh no, that's 4. Okay. 1 more minute to think of them yourself.
I think I'm back to them.
You can't have a methyl and carbon 1. Right?
Can't you?
No, because like.
That's also
Okay,
a
we'll talk about that when we go over it, right? It's illegal, but
See,
yes,
I
I am.
told you.
See, this is why.
Yeah, if you
Not
have
hard.
one, it's
Why
gonna
I
be
chose
10
you.
Like, if you do this, this is still pentane, right?
Yeah.
This is not 1-methyl butane. This is pentane. You just went like this and like that. Like you took your arm and you went like that.
Great.
Hexane. Hexane.
How many more than one?
Oh yeah, I mean if you want to be spicy. All right, I'm gonna go over the answers, so let me get your full attention. So how many isomers with the formula C5H10 have structures that involve pi bonding?
2.
I'm gonna be clear the way we're answering this because we haven't learned about stereoisomers yet. We're answering only for structural isomers. So let's take a look. First one, did you get one with an alkene on carbon 1? Like 5 carbons in a row and an alkene on carbon 1. How do you know this is C5H10? It's the formula for an alkene, right? Do you have to write the hydrogens? No, but you can just approve it. This carbon would need how many hydrogens? 2. This carbon would need 1. This one would need 2. This one would need 2, and this one would need 3. So you can write them out, but do you have to on a multiple choice question? No, that's what I'm just trying to say. All right, so this is 1. This is pent 1 ene. On the actual test, I am going to ask you to name them along with the isomers, just so you're aware. That's why you see me practicing with that. All right, next one. Could we do 5 carbons in a row, but move the double bond from carbon 1 to carbon 2? Notice there's a pattern here. We have to move stuff, because you'll see why. 3, 4, 5, like this. If you write the hydrogens in, you'll see why this is a different isomer. How many hydrogens does this carbon get?
No, you can't do that.
3. Already noticed that that's different. 2 here and 3 here. You've arranged your atoms in a different manner. This is an isomer. H, H, H2, and H3. You don't have to fill these in. What's the name of this? Pentylene. All right. That's 2. What else could we do?
There's
2
methyl,
Yeah. We can go 4 carbons in a row. Put a double bond here. And put a
That's what you did. That's the.
methyl.
That's better there.
Do I have to write the hydrogens? Please tell me I don't.
No. Yes.
Can I move them? Okay, fine. H2, H3, H2, H3. What's the name of this?
It's 6.
Oh, this gets no hydrogen. Sorry. 1, 2, 3, 4.
It's 6.
What's the name of this?
It's because you can make 10.
2 methyl. 2 methyl. Fuse.
Oh, yeah.
1 ene, or 2 methyl butte 1 ene. All right, number 4. and move it. Like literally you're breaking the bond.
Wouldn't it be the same?
Well, let's check it. One
You can,
is where, because of where the double bond is, absolutely. This is carbon 1, it has to be 1. 2, 3, 4. 3 methyl, butane.
Okay.
See if this makes sense. Go ahead, yes. This is not memorizing anything really though. It's just,
you gotta know all the rules.
Spatial awareness.
yes, go ahead.
You don't know the rules.
Well, bless you. Can you repeat that? Correct. Anything that alters the end of the name is where priority goes in numbering your carbon chain. So every functional group, you would number the carbon chain closest to that functional group. Alkenes count as functional groups because they change the function of the molecule. Alkynes do too. All right, are we good with this one? Do I have to fill in the hydrogens? Okay. Carbon 1 gives how many? It's 1. It's 2, 1, 1, 3, and 3, right? 3, 6, 7, 8, 10. You don't have to, like if it's a paper 1 question, you don't have to do that. You just have to write like the different organizations. All right. Is there another one?
Yes.
4-methyl butane.
No, there is no 4-methyl. There can't be. 1, 2, 3, 4. That's not methyl. That's pent, right? Continuous carbon chain, 5 in a row. No 4-methyl, not a thing. Yes. There's a line. Well, when David comes back. Well, only 1 out of the 10 when David comes back. Same thing. Same answer. 5. You can move the double bond. We didn't do that yet, right?
Oh yeah.
So 1, 2, 3, 4. Double bond goes on carbon. 2. Methyl can only go on one of these 2 carbons. If it goes on the end, it's not a methyl. Are we good with that? So maybe here?
Yep.
Right, that's different. Prove it by naming it. 2-methyl butene. Does anything else have that name that you did?
No.
If the name is different, it's a different molecule. You've arranged the atoms differently to come up with that name. How are we feeling?
Yeah.
Not the easiest thing, right?
Relative.
Are you getting the idea, the pattern of what to do? Starting to click a little bit? Yes. I have seen, well, unfortunately for you, this is 1. How do we know this is 1 mark? It's multiple choice. On a paper 2, it would be worth significantly more. You would see if they asked you to draw them and name them, it would be 4 marks usually, 1 for each one. Or this one would be 5, 1 for each one that you have to do. Like if it was a written question. What? I mean, I can do it pretty fast, but I do it skeletal is why. I don't draw everything out. I do it skeletal and then I just do all the rearrangements. Like I know that it's alkene or cyclo, 1 double bond or a ring, and then I do all the quick arrangements and just make sure I don't accidentally draw the same thing twice. That's what I do. I do speed run paper 1. Last year when they gave us the paper 1 back, I took it and saw how much time it took me. Like 30 minutes with 59 out of 60. Hello, wait, what? Yeah, sometimes I too quick read and then like misread something. It happens. But I'll take your test after like the exam series is over. I would take them all before they release the answer sheets, just so I know what they were.
It was 5, right?
What?
The
5 was the answer. So 5 is the answer. moving on. We did 5 carbons in a row. We did 4 carbons in a row. Was there an option for 3 carbons in a row? If you try to do 3 carbons in a row with a double bond, what's going to happen? If you do 1 on the top and 1 on the bottom, you've broken the octet rule. It doesn't work. If you do like 2 on the top, you're just like, well, I'll just do that. That's butene again. That's not protein. Got it? So that doesn't work. 3 carbons in a row doesn't work here. So the answer is 5 for what we gotta do. 5. And yes, you would get 1 minute and a half to answer it, along with every other paper 1 question. All right, so we're gonna continue. Let me get your attention again. There's more. We've literally just covered one thing. What's an isomer and how to draw them. Now we got to go to types of isomers. So there are 3 specific types of structural isomers you're responsible for knowing about. Position, functional group, and chain. So pay careful attention because there are 3 different types of rearrangements structurally that can happen. Every rearrangement we have done so far has pretty much been chain, which is moving, changing around the carbon chain. So let's see what everything else is. Position isomerism. And yes, you got to know all 3, so you got to study all 3. In position isomerism, your functional group changes position on the carbon chain. So to be specific, changes position in the carbon chain. So an example of a position isomer would be this. I'm just going to give a different one that's in the example. This is a position isomer. And yes, it's much easier to do it skeletally than to do it displayed. So you're going to see me work skeletally most of the time because lazy, I don't want to draw the hydrogens, waste too much time, and they look confusing if you're struggling. What is the difference here in the 2 that I've written? What happened to the OH? This OH is on carbon 2, whereas this OH is on carbon 1. So if my functional group is on different carbons in the carbon chain, we call these position isomers. So far, so good?
Mhm.
Functional group changes position in the carbon chain. That's it. You may be asked to identify position isomers, functional group isomers, and chain isomers, so you got to know all 3. So, oh my gosh, we're going to skip that because we already did enough of this. Functional group isomers. This is the second type. In a functional group isomer, you've got the same molecular formula, but you've actually changed the functional group. Meaning, alcohols, for example, and ethers are functional group isomers of each other. This alcohol has how many carbons, how many hydrogens, and how many oxygens? This is also called ethanol. I just called it. It's got 2 carbons, 6 hydrogens, and 1 oxygen, right? If I were to write its molecular formula, it would be C2H6O. What's the molecular formula of this ether? 1, 2, C2H6O1. 1 oxygen, right? The molecular formulas are the same, but the functional groups are different. By the way, there are specific functional group isomers that exist. I'm just going to write them down for you. Ethers and alcohols are one variant. So alcohol can go to ether. Aldehyde, what do you think a functional group isomer of an aldehyde would be? Let's just pick a random aldehyde. If you move the position, could you get a different function? Yes. Could you get a different functional group where you move the functional group around and you get a different functional group by moving the atoms around? but keeping the molecular formula the same. That would be a ketone, right? Because it would have the same amount of carbons and hydrogens and oxygens, but the functional group is indeed different. So you should write aldehydes to ketones are always going to be functional group isomers of each other, actually. And it's just because you could move that around. And there's one more. Carboxylic acid. They always have the same functional group isomer. Absolutely correct. Perfect. Carboxylic acid. If we were to move this carbon chain around and we took some of those carbons and put it on the other side, that would turn into an ester. So carboxylic acids, their functional group isomer is always ester. So you may want to write this down because it'll help make some paper 1 questions a bit quicker instead of having to draw everything out to figure out which are the different functional group isomers. And so once again, just to repeat what functional group isomer is in this, you've got the same molecular formula, but the actual atoms have been rearranged to give you a different functional group. But that is why both of these, and that's why the wording is funny, both of these are called carbonyls, and both of these are technically called carboxyls for that reason. Just the atoms are shifted around. All right, so now that I've given you that information, you are prepared to, hopefully, answer this paper 1 question that follows. Which pair of compounds would you say are functional group isomers of each other? I'll check yours, but I'm not going to really answer yet. Wait. I'm gonna let you think about it. Then I'll answer it.
I'm a
I don't think it's I think it's either B or D, and I don't remember talking about love, so I don't think it's love.
Esther.
Yeah.
Oh, I didn't take my paper. Yes, Esther.
Oh yeah. It does.
Turn into carboxylic acid.
Makes sense for me.
Carboxylic.
Yes.
Could you draw them all out to figure it out?
Carboxylic.
Is there a quicker way?
It's the way they end the ending.
Oh yeah.
You memorize the
Yeah.
you would know exactly what the name is.
So let's take a look. Why isn't it A?
Because of alcohol and the other one with an A. I don't know. Aldehyde. The other one. I listen.
It's okay. It's a Friday. Life's hard. All right. Why aren't these considered functional group isomers of each other? What's the reasoning? What's the actual reason? They have the same amount of carbon. They have the same amount of oxygen. What's wrong, Justin? Double bond, the other one's not. Double bond means that the amount of hydrogens are different, right? Reduced by 2. So it doesn't have the same molecular formula. Get out of here. That's also why D is wrong, because nitriles have a triple bond and amines don't, right? So get out of here. Hexoamine and hextuene is the same functional group, right?
Yes.
Yes. Yes, you may. Go take the test. And so we have this. Yes? It's B. And you could have also just remembered count the amount of carbons, make sure they're 5 in both. If it's one's an ester and one's a carboxylic acid, that's it.
C, it's structural.
Structural isomer of the, you move the position of the functional group. So this is actually called a position isomer. But they didn't ask for position isomer, they asked for a functional group isomer. So be careful there. Yeah. Yeah. It would work. Just count the carbons to make sure bases. Because they could give you, right, say, propylpropanoate, and then a carboxylic acid that has a different carbon.
I did not.
Yeah, check the bar. No, that's the way. Yep. All right, we're gonna continue. Any other questions here? Are we good? I do need you all to quiet down. All right. So out of the 3 types of structural isomers, remember there were 3 types. We have looked at 2 of them. The first one we looked at was called position. Position means you change where on the carbon chain the functional group is at. Yes? So this example, hexoene to hextuene, that's a position isomer. The alkene has been moved from carbon 1 to carbon 2. The second one we looked at was called functional group, which literally means that the 2 isomers have different functional groups. Yes? The third one is called chain isomerism. And that's the one I'm about to explain now. And that's just changing the carbon chain, the length of the carbon chain. So everything that we did at the beginning, all the isomers we looked at before we looked at this topic were all chain isomers. When we take butane and make it 2-methylpropane by moving the methyl group, that's going to be a chain isomer. So we'll take a look at that now.
So these are all the types of
These are all the types of
structural
isomers. Structural isomers have 3 types: position, functional group, chain. How can you move the atoms around in different ways, basically? You can change either the position of the functional group, the entire functional group, or just the chain of carbon.
And if we did this, then we would get the max amount of isomers in the
Yeah, exactly. Yeah, if they give you an alcohol, they're being a little mean, but it's possible. All right, here we go. So, chain isomerism. Do you need me to go back, Janie? Janie, do you need me to go back, or are you good? You're good? All right. Chain isomers, 3rd type. All you're doing here is you are moving the carbon chain around. Butane to 2-methylpropane, same amount of carbons and hydrogens, but instead of having 4 carbons in the chain, you have 3 carbons in the chain and a methyl group. The interesting thing about chain isomers is there is no change in functional groups. You're just changing the carbon chain. So just like if this was 1, 2, 3, 4, 5, 6, and you went like this, 5 and 1 there, these are considered to be chain isomers. Are we okay with that? Changing the length of the carbon chain, moving and getting your different methyl groups, those are called chain isomers. That's the 3rd type of structural isomer. Now, I think, let me double check it. We have a couple more questions to go over, yes. We have about 3 more slides that we need to do. And then I had debated, I left some extra space and time. I feel like you're all pretty tired today. So I'm going to wait to cover stereoisomers till next class because believe me, you'll prefer that I wait to cover. If you struggled a bit with structural isomers, just mentally prepare yourself for stereoisomers. They'll be coming. That's when you have to see things spatially, 3-dimensionally. So we'll be looking at that on Tuesday. But we still have 3 more slides to cover, and then I'll tell you what your alterations to your homework is. All right, ready? Yeah, I had considered, I'm not going to rush it because I need you to understand it because Cambridge loves to test it. It's really important. I built in some extra time. Yeah. All right, here we go. So, checkup. I'm going to give you a little bit of time. And this is for a stamp. Draw the structures. Give the names of 3 isomers of C6H14. So that's the one that I had you build at the beginning. So now you make some 3 isomers of that and give me names. You have it already? All right, let me bring this in. I just need 3. C6H14. There's way more than 3.
Skeletal? I mean, if you understand skeletal, it's perfectly.
If you understand skeletal, that is the way to go. It is easiest. Then draw,
Confuse
then
you.
display it.
Yeah.
Then draw all your carbons and hydrogens and skeletal. All right, once you're ready, raise your hands. I'm giving you some time. Like I said, we have 3 more slides to go over, and then we're gonna stop for the day. And I'll explain what your alterations to your homework is. Yes. Did you name them? Give the names. This is the check to see if you are following along, if you're good so far with what we're doing.
Yeah, fish smell.
5.
You do have the molecular model kit. You could use that to your advantage. 6 carbons, 14 hydrogen. Perfect.
10, 11, 12, 13, 14, 15. 1, 2, 3. 1, 2, 3, 4, 5. 10. I got 15. No, very invalid.
Is it illegal?
This is your legality. Don't you dare break this.
I don't think I did.
No, because that's 15.
That's
You have
15?
15 hydrogens.
Do I not want to count?
No, you don't, because I just did that. So that's 15.
No, alkene changes the amount of hydrogen. That will be C6H12. We only 15. Yes.
1, 2, 3,
All right.
4, 5.
Yours is perfect. All right.
That's 10. 12. 13, 14, 15.
No, because this isn't 5. This is not
Oh, because
hydrogen.
it's 4. Okay, right. Oh my gosh.
Brother.
I was having a seizure over
Brother
here.
in Christ.
4, 5, 6, 7, 8, 9.
You can play around with that.
Oh my god.
Like move them around, yeah. You could do that.
If you lose the weight, I do. It's
I would,
easy, right? If you take
for me, I do it skeletal unless I perform. Unless they say draw the play.
Shut up, Julio.
Methyl. Methyl. 3 methyl.
3.
I put it.
Oh,
Oh, yeah.
wow.
3 methyl. I put it in the middle.
It is different.
Oh.
3 methyl propane. Right? Propane?
Yes.
Propane?
Oh, was it?
It is different.
2 methyl.
Can I bronze these carbons together?
Raise your hand when you're ready.
Can I?
And we just have a couple more slides to go through.
2 methyl.
We got a couple more minutes till I move on.
Look for 2 methyl. Oh, I did 3.
Yeah. That. Good. Good.
This is right. I'm always right. I can't be wrong. This hexane. Oh, I didn't draw it.
Propane is 3 carbons. It has to be 5 carbons.
Failed me.
Propane is 3. Meth and propane. You need 5 carbons.
insane.
No, you should
No,
know.
which one?
What's the 3 right? It's 5. 10.
Why didn't you say it was
You said
10?
it was 4.
I said it was 5.
You said it was
You failed me.
You failed
You
me.
failed me.
You failed me.
So it's pentane? What is this?
This is 6 in a row, though. This is hexane. This is not 1-methylpentane. This is hexane. All right. Now,
I do know what I'm saying. I think it's I did you. I looked at yours. I counted 4. I said 4.
Oh, so you can't count.
I can't count.
Why?
We've been over this. I can only count 4.
there is no such thing as a 1-methyl.
By the way you drew this is just wrong.
It's just happened.
has to be on top of each other. You're wrong though. No, that has to be on here.
Why?
Like this labeling wrong.
Why?
Because it's not on 2, it's on 3. I'm having some like atheism. I think my brain's really working out.
5.
That's so funny. And the long.
They're all in a row.
You already told me that too.
There's not one methyl.
Oh, yeah.
You may want to write a note. You cannot put ethyls on N. You cannot put methyls on N carbons. You cannot put methyl on an N carbon. It extends the chain.
3, 6, 9, 10.
Maybe write that note if you made that mistake.
13, 14. I got 15 again.
I'll work through it, but I think so. All right, so let me just check raised hands for one more minute.
Ignore this.
Wait.
Yeah, diamond. Diamond. 2-methyl diamond.
I moved them back.
Yes.
Because I better.
All right, so we got a couple more questions to do. Just to be clear, it's helpful to just recognize this is an alkane. How do we know this is an alkane? So I do need your attention again, just for a few more minutes. How do we know this is an alkane? Right. So if you know that formula, it's going to make your life easier because you don't have to write everything. You can just do it in skeletal version. So 6 carbons, 1, 2, 3, 4, 5, 6, and trust it will be 14 hydrogens. Trust? That's the formula, right? That's an alkane. If you don't know that formula and you don't trust, then you have to draw it all out, displayed, right? So your choice, but I don't want to do that. So if you know the rule, it makes it simpler. What is the name of this one? Hexane. Now what an isomer is basically pop off a carbon and move it somewhere else, right? Instead of 6 carbons in a row, you could have 5 carbons in a row and move your last carbon to one of the ones in the center. And you get 2-methyl pentane. Then you could also move that carbon here. And this would be 3-methyl pentane. Now, are these all your options? No, I just said to stop at 3 because we could just sit here for a while and keep drawing all the different variants. The more carbons there are here, the more variants you're going to have. And then if I introduce alkene or alkyne, the variants increase a lot. So on a Cambridge exam, I typically see if they are asking you to draw out the isomers, it's usually 4 that they ask you to draw. That's what I usually see. How to make, well, you have to make 4 and then name them usually together. All right, which statement is correct? Let's take a look at this. 2,2-dimethyl propanoic acid. Is that an isomer of propylmethanoate? Yes or no, and why?
Yes. 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 I stand with yes. I already said it and came back out.
So we know carboxylic acid to ester, but count the carbons. How many carbons are in this one? 3 plus 2 is?
5.
How many carbons are in this one? 3 plus
1 is 4.
1 is 4. Is 4 and 5 the same? So A is not the answer. B is 2-methylbutane 2-ol, an isomer of hexane 3-ol.
No.
No.
Why not?
because the carbon.
Bute is 4, meth is 1, 1 plus 4 is 5, hex is 5 do not equal 6, not the same molecular formula, therefore cannot be isomers. They have to have the same molecular formula, so same amount of carbons, hydrogens, and oxygens, but a different arrangement. So not B. C.
C is right.
3-methylbutane to 2-pentanal. We already know ketones and aldehydes are isomers of each other. We just have to get the count of carbons. 1 plus 4 is 5. 5. 5 equal 5? Answer. Why isn't D the answer? 5 carbons and 4 plus 2 is 6 carbons. 5 does not equal 6, not D. So,
all about adding.
yes, it is. Okay, so how long would this feasibly take you to do if you knew what you were doing? Maybe, it shouldn't be too long, right? Whereas, a question like how many isomers could this possibly have could take significantly more time. Once again, know where the easy marks are at, know where the longer marks are at. You always want to go for as many of the easy marks as possible first. All right, so we've got, this is our last slide for today. Methylpropane is an isomer of butane. Words. Explain why. Why do we call these isomers in the first place? What are they asking us? Go ahead, Ben.
They have the same number of carbons and hydrogens.
Okay. Or same molecular formula, but that's absolutely correct. So we have the same amount of atoms of each element, but the arrangement of atoms is different, right? Different arrangement of atoms. Or you could just say they have different structures if you just use the straight up definition, right? So the molecules have, or you could just use what they say, butane and methylpropane, if you're not sure they're molecules and you're like, I don't want to mess up. The molecules have the same amount
Of atoms of each element.
But the structures are, you can either say the structures or the arrangement of atoms are different. And we know that that's true because of the different name. Different name, and it shows like a different arrangement. One is to say what you have the same amount of. One is to say what you have a different amount of. So remember, iso means something is the same and something is different. Same amount of atoms of each element is the one mark. The second mark is to say that the structures are different, or the arrangement of the atoms are different. That's the second mark. It's actually a really easy 2-mark question if you think about it, because it's literally the definition. So should the definition of isomer be in your things to study?
Yes.
Yes. All right, here's another mark, paper 2. What is the specific type of isomerism we are looking at? When they say type, this means you technically have a word bank in your brain, or you should. It should either be, it would either be position or functional or chain. And here we don't even have a functional group, so it technically cannot be the other two. It has to be chain. Yes? So chain isomers. So that's 1 mark. Good with that?
Yes.
Okay. Let's talk about homework and rest of the day. So the homework 3, I put both structural and stereoisomers on that homework. The stereoisomers questions start at question 4. So I'm going to make the homework not due until after next class's lesson, so it won't be due until after Tuesday. You can choose to do those first 3 questions if you feel comfortable with what we've done so far. or you can wait to do them until after Tuesday. Like for a lot of people, it helps if you do the questions right away. Then look through the rest, and if it says stereo isomer, optical isomer, geometric isomer, don't do it yet. Unless you want to teach it to yourself before I teach it on Tuesday, up to you. But I'm going to make this due after next class, like after next class. But I'm giving it to you now, so if you feel okay with it, you can get started. Okay?
Thursday.
It'll most likely be due Wednesday night.
Wednesday.
But I'm giving you the homework now so you have it. So if you feel comfortable with what we've learned today, you can start working on it, at least the first 3 questions. But I went a little bit slower because I knew that this needs some love to understand.
This is English. Okay.
After the class, after the week. After the stupid.
Or at least, and if they did, I don't remember. I would hope it's just
I know so little.
okay.
How do you have so much more than me?
There you go. Remember, the functional groups homework is due on Sunday. I'm extending the length of this one. It's not due until Wednesday. You should actually write it.
Oh shit! I thought it was just a position and say I knew it could be functional. You could like help test it.
You gotta follow up.
Yeah, I'm like, where is it?
It's a little bit confusing because we can't use terminology. But yeah, what strikes me is a
I said
functional group.
it doesn't mean I know what I'm doing. It just means I'm like, you know your fuck ass mouth. That's basically what I do for this class.
I wonder if you're working with it easier, like on the stage. You just like work with confusion with the black people. So that then- That's like the most fun, so I think it's-
It looks like it. I appreciate it. I appreciate it. You're funny. Then you can. The numbers?
So, yeah, you didn't put different books in it, other than normally to have.
I know you guys are playing. So you guys got some Disney movie starting with one.
But if they just say what is cars? Yeah. That's like
I'm so gonna get to it, man. I'm so sorry. My brain is just so mad. Now he can see it. Yeah, you guys.
She said Disney and Pixar, and it's from True.
I forgot.
You might have that work in the next week. You gotta practice. How are your brains?
Right.
Fried? Empty.
Exactly 9 minutes.
You want to lose so badly. So badly. Like every chance you get, you want to lose.
Yeah.
No, right.
Yes. You're welcome. Yeah. Can you take your model kits and disconnect them and put them back into the Ziploc bag?
Oh.
Be glad I didn't go at ultra speed and also do the other isomers.
Thank you.
It's getting better. Next time you can touch them like 3 days. I do have like model kits like built to like show what's going on. with the angles and everything, like what I do with the dashes, they're coming back to class. Tetrahedron has very different dashes. Yeah. We're gonna be looking at something tetrahedral has two spins. There's two different ways they can spin.
I know you're,
Two different types of ice.
hypersonic.
Don't worry, I'll teach you strategies next class. I mean, like saying. Actually, it's really important for anybody who wants to be a pharmacist. One isomer, for example, can help cancer, like kill cells of cancer. Just based on the different.
Good afternoon, Golden Lions. The Carlos
A little
Garcia.
messed up in the creation of that drug.
And just to tell you to hear a few
Just
important
giving someone poison instead of a cancer.
uniform. Outwear must be solid colors, red, black, or white only. Sashes must be worn only on Fridays. Uniform can be purchased online at
Well. But if you're
or
interested in that, like whatever you're
do not keep
interested
that around your neck at all times. Arrive to school on time between 7:10 and 7:15 when the tardy. Class begins at 7:20 a.m. Progressive discipline plan is in effect for dress code and tardy violations. You may only eat lunch no eating in the hallway. If you bring a bite home, you should bring a lot.
and there were people who drive me back to more than I know.
The building is not accessible until further notice. All pickups and drop-offs are to occur in front of the school. Take into account that leaving 2 minutes earlier on time, and traffic will build up. Daddy was participating in the Do the Right Thing program. The entire school staff is the democratic bullying, exceptional measures, innovating in the crisis. Nominations will be submitted each month. Each nominee receives a T-shirt, certificate, bumper sticker, letter of congratulations, certificate, and 2 tickets to Miami Marlins game.
That's what Jason did.
You were on a sale now for $60. Price will increase after December 20th. Please visit www.yearbookordercenter.com to order. The order number is
It makes your senior year
210.
actually quite nice. And it would also give you, if you've done all your exams.
It's time. N8, S, ancestry game not wrapped. The nations will be collected in the office and Mr. Missouri. The results were awarded by our first collector.
And the nice thing about it is that you don't have to come high school classes. So you're just using your college schedule for your 12th year. You can sleep in if you want to.
Every email you set up your online account.
You pay how much college you want. It just needs to be enough to
Senior, it's time to make your senior quote for the year.
Well, that's not.
Check your email to fill out the form. See if it's real, if you have any questions. The IU's annual lip sync battle is coming soon on Tuesday, December 19th. Sign up to compete with your group or your friends or solo for a chance to win a gift card to the place of your choosing. You can sign up after the list is here. This is our mandatory.
Like,
It will be
there's
held
some people who have like internships for 2 classes, so they just leave at 12 and then do an internship somewhere.
Attention students, District 9,
And then there's like office days you can do for like a period.
Lucia
So it depends on
Santos,
how
along with the assistance of SSEA, was collecting toy
the harder
donations
you work, the like older you get, the better senior
Each
year.
unwrapped toy donation was a community service app. You may drop
If you
off
slack
your
and
donations
test it
like
like
an
later
office.
year, senior year, you
Last
start.
minute drop off your donations
Because you're
Friday,
already tired.
Friday, December 5th.
Oh.
This concludes our afternoon announcements from the ACIA.
Oh, your spell casters are too strong. I thought they were gone forever. That's so sad.
Yeah, we all love that, break, break.
I didn't know that. I didn't know that.
That's their thing. I have to be true. They tried to-
I'll play it better next time. You could have nice.
You know what you should play?
I got rid of it.